First to comment, when a baseball game is underway, there are 18 players on the field. I thought that was a trick question. There are 18 players on the field, two teams. Sorry, just for fun. Question to.
Well, there could.
That's true. That's true.
13.
Never mind. You got it. That's right. The question was about pedigree, I think, of models.
Pedigree?
Yeah, the question on that definition that was provided, more formal definition, was pretty hard for me to remember and recount to others. I was just questioning, could a surrogate for that definition be the who, what, why, when, where, and how of models? Is that accurate enough that if you're trying to communicate to colleagues about pedigree, would that be a reasonable?
Yes, and I use the term definition, but I guess that probably was more of a quote than a definition that I put up there. But I think that, yes, you are probably getting to the essence of it, and simplicity is a good thing. We need to maybe see if we can work with that and create some kind of much simpler definition.
It's probably appropriate to make a comment. In my travels, maybe Donna knows this is just as good. I'm surprised at how much effort is put into making these models, but then they don't treat them with any respect afterwards.
That's true.
They file them in a drawer somewhere, and somebody says, well, George has that model, or whatever else that goes along with it. And so I think research into this is appropriate, because think of all the value that's in there and the experience and so forth. So,
Yeah.
okay, thank you. Next question. Who has another question? Go ahead.
So I'll help Ricardo on the first when we have another question.
Oh, you're going to do a two-parter. Okay.
Monte Carlo simulation and baseball fit very well together. But 45 years ago, I played a game called Stratomatic Baseball. And you'd flip a little thing and you had a card for a player. And each year the company made you buy a new deck of cards. All the card was the data you showed in fractions, directly connected to Monte Carlo simulation. When I first learned Fortran, I wrote a program to do that, and it was all in the cards that were mentioned this morning. And that was when you took your cards to someone to read, and I didn't look enough to see how to get a random number generator, so I had 100 cards with numbers. When I gave it to the guy to run, I said, oh, I don't know why this is working. I shuffled the last 100 cards and said, here, try it. At the end of the day, it was a Monte Carlo simulation. So I think it's a cool thing, because it gets the kids looking at the baseball card, and you can make it come alive.
That's cool.
Anyway, I was reliving.
Just a comment. You're reliving
That's
your
cool.
baseball past.
That's cool.
Okay, part two.
On the question on NDD, you talked about integrating models, and I wondered what your observation was. Presumably, you want to discover and search over the whole space and try to find a system-level optimal solution. But I think one of the issues that will come up is you'll look in, anytime you optimize, you go to the boundaries of your model, and you want that to happen. What observations or suggestions do you have of how you manage all those submodels and say what's their range of applicability, and how do you describe when you're getting away from your normal design point and buyer beware?
I think that actually goes to what Donna was talking about a lot. The presumption is that if you have lots of models and you're integrating those models, you're building a model library and using those models as credited and parts of that library. They're not in the library unless they're credited, right? The problem you're talking about is when I get all those models together in a federated interrelationship, how do I know that they're all part of that credibility? And then when I use patterns to analyze those models, am I analyzing the right pattern, the right part of the model? These are tough questions that we haven't worked out yet.
Well, I guess to that point, the curation thing, I've been doing that under the term certifying models for about 20 years at our company. And one of the first questions we asked, what's the range of applicability? And we forced people to write that down.
Yeah, model intent is critical.
Or else they'll wander into a region where your model's not believable.
Right, and I think your speaking to the point that I mentioned about in our research, we hope to look for these precursors of what has been going on and is going on in organizations that can inform what this larger model curation practice should be. So we're definitely interested in the kinds of things that you've been doing.
From a company standpoint, it costs money to expand that envelope.
Yes.
Of course.
So we're always being faced with that battle.
Yep, but we're going to make money in the future on models too, right? So.
Next question, go ahead.
John Barrett, University of Maryland. I have a question for Bill. Nice presentation, but the comment I want to make is the following. When you push the humanity in model complexity more often than you want, you lose propositionality. There are many, many examples of that where you push the humanity and then you cannot compose. And by propositionality, I mean you can say something about the properties of the composition and the properties of the other requirements of the components. So that many humanity has to be careful. Any response or comments? Because there are many examples in engineering, either within a domain or across domain, that what I'm telling you is very novel.
So I think as I understood, the warning is you can create complexity beyond which you lose utility, right? So I think one of the important things that we think about patterns, certainly agreeing with your point, is compared to maybe this library discussion we just had, is we're interested in patterns that represent whole systems, not collections of smaller subsystems in a library. And then in that whole thing, it's abstracted to represent the generality and the relationships between them. So if you're willing to make the investment in distillation, you can drive down the apparent complexity because you're representing whole classes of things. And the coverage is still in there, but you've separated the fixed part of the model from the variable part of the model. And it's at least given your point is still good, it's a way to at least manage the complexity. So very good point, though.
Next question? Another one, okay.
That's what Donna. The problem, very good points you make, but I would like to put it. The problem we're running when we try to maintain models is typically heterogeneity of representation of the models, especially if you're running over long periods of time. So you say you're Atheon or
Right.
Martin or Boyd, and you get all kinds of models through your history, that they are deposited, but they're not all in the same form.
Correct.
So one of the issues that I don't have an answer, maybe you have initial steps to, is how do we assess this database of the model through patterns or others to find similarities so that we can actually bring them up and use them instead of trying to recreate them in the beginning. Because I don't think any company will accept the point that, okay, you don't know, so this is great, but now I want to do it this way. Because they're going to ask, well, for 50 years I was doing it this way, how do I link all this model?
Right, and we haven't explored this too much, but I believe that there's probably a good research project to look at what kind of technology could do that. The sort of analogous thing that we have done is that we were looking at a problem where capability documents for military systems over time, it's the format, the templates are changing, and yet when you ask the question, do we need a certain new technology? First, you want to look at what you have. Do we already have this? And so there was some recent research that MIT did for Department of Defense that was looking at using semantic architecture and natural language processing to kind of go through the documents and to look for how could we pull out what those capabilities were regardless of what was there. So it's not going to be exactly the same thing with models, but I think if we get some really smart people working on that we may be able to apply technology to get toward the issue that you're talking about.
The practical question is, do you know of any efforts where people are trying to use either text search or any kind of form?
Yeah.
Trying to market the use of more modern models we have, or you're using patterns for the same thing?
Right. I'm just starting to explore some of these things, and I'm finding some evidence in other fields of curation that people are using, machine learning or feature engineering and so forth. I don't have enough knowledge gathered to be intelligent enough to say this is what we should explore, but we're definitely hopefully headed down that path to do that.
Question?
Yes, in terms of when we say the term model, in the systems engineering environment, that artifact is a mix of elements and descriptions that that represents what we realized in the system, but it's also full of information and artifacts that are attributes of the engineering process. A requirement, for example, is not realized in a system. It is an artifact of the engineering life cycle. So when we talk about those kinds of models, I have no questions about anything you said. In fact, I concur with all of it. My question is, when we start talking about the term digital twin, given that we're starting to take a much more serious and life cycle approach to the development of what I'm going to call our systems engineering models, where does I haven't heard the words constructive and virtual simulation used in this environment. Where do you think those practices, which by the way, I remember the days of model-based acquisition, where we simulated everything first and it went bust because we couldn't afford it. Do you see the development of virtual and constructive simulations as part of this digital engineering life cycle now coming back? And if so, how does that tie into that?
Well, we certainly do at Sandia. We're modeling a number of different constructs through combinations of system models and Simulink and physics models and that kind of stuff. We're not at the end game yet, but we are certainly making roads that direction. I'm not sure if that answers your question. But yeah, I think it's important. If a system model is executable, it's much more useful.
I think if I'm getting your question, I think there's some really interesting things going on with using synthetic environments and digital wargaming in terms of early life cycle to assess feasibility of different products. And so there's some really active research, for example, at MIT Lincoln Labs that's doing some amazing.
My question was, I think some of the questions that we want to ask may require a form of model that's beyond the kind of SysML,
Sure.
And in the past, those were typically done with virtual and constructive simulation. My question is, as part of our advance towards the future, do we believe that there's going to be more emphasis, or at least bringing that into this enterprise? Because we really haven't talked about it much tonight.
Yeah. Well, I think personally there will be, because just the availability of high-performance computing and so forth, we have the opportunity to do this, because in the past we were so limited about what we could do. And I think, we should be thinking about the future in that regard, in my view, but other people want to comment?
Okay, next question.
So I enjoyed all of your talks. That was great. This question's for Bill. You brought up emerging engineering disciplines, and that really resonated with me. It got me thinking about patterns as far as medical and DNA and RNA. Is there any comparison with natural systems and patterns, seeing if we can get to predictive defects the way that we can get to predictive sicknesses and diseases in humans?
So is your question is using the life sciences as an analogy, or it was about the life sciences?
The life sciences analogy. Is that study going on?
I see.
As
Well, so it's interesting to think of in living things, the DNA that's been evolved over time as a pattern, because it certainly is, and it's a highly configurable. By configuration and patterns, we mean the setting or unsetting, the population or depopulation of the elements of the pattern, and then the numerical variation of the parameters of the pattern. So it has very specific meaning. It's very much like, it's quite analogous to what goes on as ribosomes read out DNA. It's a pretty direct analogy there, actually. And so that says, I think if I get your drift, then we can study a little bit how evolution has worked in living things. And it's quite like that feedback loop picture I showed you of what future system engineering might look like in terms of how we acquire new knowledge by experience and then deploy it. So I would say yes.
Thanks.
Next question? Are we out of questions?
Can I ask a question on Saturday?
Okay.
But this is, the answer is not right, my question.
You're feeling Ricardo's being looked out for questions. I'm going to ask you a baseball question.
Ask me a baseball question.
The pitcher, I want to try to throw a fast ball or curveball or something. What kind of feedback I use? Optical, haptic, force? What's the most important?
What kind of feedback?
What's the most important feedback?
High speed course. Can I do it by just optical feedback? What's in my hand? Can I do it by haptic, by force?
Oh, yeah, I think most of the sort of human system feedback is kinesthetic, so feeling, getting feedback from sensors that are in your body, and then
What do you think the answer is? Visual, haptic, or force?
depends on the individual learner. Well,
Try to do fast ball by looking at it, you're never going to make it.
the answer is 9.
There are papers.
There are 9 ways.
9 is no in German.
So Ricardo, I remember a paper by Dr. Behill. Remember that? It was the science behind a rising fastball.
Yeah.
And when I attended it, he was talking about the psychological aspects of a rising fastball. And important timing was where you had to throw that second ball, a 3-seam fastball, then followed by a 2-seam fastball. You had to do it within 18 seconds, otherwise your brain had reset before that time.
That's right.
To give you the optical illusion, right? So there's interesting science out there.
Well, so I'll tell you, because I know all of you are superstitious, I'll just give you a story. Terry Behill was from the University of Arizona, same department as me. When he retired, I was given his office.
Well, that is suspicious.
It's very suspicious.
Office number 9.
Tell you.
Paul, you have a question?
Yeah. So just a little background. Paul Nelson from Northrop Grumman. Background on this question. So I love Moneyball, by the way, one of my favorite books and favorite movies. And the premise of Moneyball is all about changing the game, right? And our track here, so this is also a question to Troy and Mark as well as the panel. We're talking about transformation, right? Using MBSE to transform our engineering, manufacturing, and sustainment. And our customers and leadership internally, at least at Northrop Grumman, they have very high expectations of this transformation. They expect that we will deliver in half the time at a third the cost. And so their measures are purely, not purely, but largely around cost and schedule. And we tend to be, as a community, very technically focused. And I'm not a model naysayer, I'm a model believer. I see religion, right? I think we are reducing the number of physical tests we have to do through simulated and digital verification and validation and real goodness that's happening. But my question is, what do you see as ways, and I see this tying all of your talks together, which were all excellent, by the way. How can we leverage patterns and model-based engineering and curation to hold ourselves accountable to that expectation that we will deliver transformative cost and schedule impacts to our programs? Do you have any insights or thoughts?
You're pushing it to me? Reason the models have come into this from a fundamental perspective is because we can no longer do things the way we used to do them, right? And so you had to do prototypes, you had to do them over and over again, and so forth and so on. So it's a fundamental idea of how is it that you make models the gold standard, I guess, or what it is you do rather than paper, right? And today's conversation about if you attended the opening with Dr. Donaldson was about how is it culturally, from his experience, how you get a CFO or the CEO and the board of directors to start thinking this way and talking about how we go about doing that. The problem with system engineering is it's not after saving money. It's after avoiding future costs. And accountants, as you know, are aimed at how much money you're spending today that you're not going to have to spend in the future, and everything has to be measured that way. And we as systems engineering has a problem with that, the fact that they're saying, well, how come you're spending all this money up front? And we're saying to avoid future costs, and because we're pessimistic, right, we're expecting the worst thing possible to happen, but they say to you, well, how do you know it's really gonna happen, right? And I prove it to you. Of course, it only takes one bad experience to kill a company, right? You guys have all received your Takata airbag recall. It's dead, right? The company's dead, and so forth. Just one mistake, and so we're after avoiding those kinds of things, but we're pessimistic, right? And so that's the common problem here: is how is it you match cost avoidance to cost savings, and that's the problem. I remember, I guess it was at Motorola. I don't know what the situation of Motorola is, but remember Galvin came in, and he said the biggest problem he had was accountants, right? And so he said that he fired them all. So I remember right, he fired them all. He says we're after cost avoidance now, not cost savings and so forth, because they were getting in the way of the whole experience. I don't know if you have anything else to add, Troy.
Well, Mark, by the way,
Go ahead, pick the microphone.
you only need one humidifier to take down a
That's
company.
another thing. So I highly recommend that you guys, those of you guys that didn't attend IS, I did a talk on this at the last IT, and it was recorded. It's on the YouTube. It's on the YouTube channel. The noise, the sound wasn't that good, but the story is still good, right? So it's a repeat of a documented experience of this cost avoidance thinking versus cost savings thinking. And everybody in that room can remember their own experience, right, with the humidifier. So I highly recommend it. If you go do your YouTube search on the INCOSE channel, it's there. Troy's is there as well, so are a number of other good talks. Donna did another one. So we recommend that to you.
We use the humidifier example all the time in teaching, but, I was just thinking out loud here, could model-based approach have helped us avoid the closure of the plant for the humidifier example? Have you worked on that yet? Or?
I haven't done that yet.
There we
That's a
go.
good one. You see, there's some of these bad experiences that you guys all know, you try to put behind you, right? Try to forget about them, right? So, anything else, Joe? You want to add anything?
Just where do you think we are as far as a practice, and how much better do you think we could be if we apply model-based methods in a very robust way? That delta in our minds, I imagine, is pretty large, right? We know what can be done. Getting there is a very big challenge, but I think that's one thing. The other thing is if we do things in models and we start having repositories of knowledge, rather than retraveling the same paths and doing this work over again, I think we actually have a baseline from which we can measure some kind of progress, right? And cost comes back to many different things. It's not just the cost of it's a failure in the future. It's many, many, many things like Six Sigma has been a big thing over the years, right? And you always have to come up with creative ways of how do we really identify cost. And I think that once we put things in models, that's going to be a lot easier. And then we can have a baseline from which we can measure progress. Right now, how well do we measure progress on our engineering? Is it more heuristic? Is it based on any kind of data and models and level of completion? So those are some things to, I guess, consider.
So it's a tough question, Paul. More discussion. But I think what I think Troy and I have and others have decided is that the technology is moving fast. It's getting better all the time. You've been watching it. But what we now see is it's going to get swamped by organizational problems. And so that's why we're trying to push this idea of organizational problems. We've got just as much problem there as we have anywhere else. So you need to be, that's why we tried to arm you with a little bit of this information. Dr. Donaldson's inputs about thinking about organizations like a system and start engineering it, step up and start doing it right is a really interesting concept. And you saw him commenting about him being booted out, right? He seems to enjoy getting booted out, so.
If you turn your question around, the NGC question about holding ourselves responsible and said, at NGC, how do you hold yourself accountable for the airplanes you deliver? You'd have an answer to that because we have engineering processes we follow for it. So the question is, why would we try to re-architect the engineering process, which is arguably more complicated, without using engineering of that? And for real, not just sort of. It's quite a different system, but it is a system. And if we're winging it there, we can expect the result that you might guess.
we wouldn't dare wing it when an airplane were delivering. So it's kind of interesting. I'll tell you a story. I had a conversation with a new engineer at a I won't give the name of the organization or the company. What they did is they trained them on what's going on in their company by sending them through various experiences, and they started them in the warranty department. And she was talking about how her warranty notice was the fact that the gas gauge didn't register as full when the tank was full. That was her thing. And so she started tracking it down, and she found out that there was many different suppliers, and it seemed that the problem seemed to be related to a particular supplier, that kind of stuff. And they gave her 2 weeks to solve the problem. And she came back and she says, I still need more time. They said, no, we're not going to worry about that. We're just going to put in a resistor into the gas gauge and then release it. And that was her. Do you think that would fly with your airplane? It's a different mental, different way of thinking about the problem.
It used to.
It used to.
They used to put 2,000 shims in a single airplane.
There you go. They've thought about it differently. That's because you guys didn't care about weight, right? Just kidding you. So, I noticed, so being from Las Vegas, I take advantage of all the cool conferences that go into there. And my son and I, which I talked about earlier, we went to the Consumer Electronics Show and went into it's like a big auto show a lot now, and all the autonomous progress was being touted, but the statement that kind of floored everybody was by the Google Waymo guys, who said, the head of Waymo said, I don't think it's possible for us to handle all possible combinations of things in an autonomous vehicle. That's what he said. And so we're going to restrict you on what kind of things you can do with your autonomous vehicle. You're not going to go off-roading, stuff like that. But we will let you stay on the freeway and stuff. That was our thinking. When as we walked down to the next section in CES was a whole bunch of air taxis. I don't know if you guys saw that or not. Air taxis, and Boeing just announced what? Greg, it was the air taxi, the new autonomous electric air taxi, goes 50 miles. And there was a number of other ones there, Bell with, otherwise. So it's obvious as you moved along, you were thinking, hey, these air guys are going to avoid all those problems. They're going to be there first with an autonomous air taxi before these guys figure out the autonomous vehicle on the ground. And so now, my son, we were sitting there talking about it, I said, I thought to myself, would I get in an autonomous air taxi? Think about that for a second. I asked the question, do you have parachutes on these things? And they said, yeah, that's a ballistic parachute. You can use it if you need it, or stuff like that. So they said to me. But then my son said, oh, yeah, man, I'm there. Okay? He thinks differently about this whole experience, and because he's grown up with it. He's just thinking about it. He just goes with it. So it's a different mental mindset. And that's what's coming at us, whether we like it or not. And so this change is happening, whether we like it or not. That's, a side trip here. Did we get to your question, Paul? Sorry. Okay. Do we have any other questions? In the back. Oh, sorry. Go ahead.
On the topic of cost avoidance, discussing with my colleague here that perhaps it's not just the accountants that fight that idea, but the contractors do get paid to maintain the system. And so I'd be curious what the panel thinks about how the entire idea might be able to be represented. Maybe one option is that the cost is reallocated toward some other aspect of maintaining the system or its performance. That's all.
So it's the customers that are part of it.
Unfortunately, it's never reallocated. I don't know anybody who accurately estimates the number of errors and redos they're going to have to do in the work they do. And so you end up building something, particularly a large thing, very expensive thing, that ends up costing X orders more. And it's that kind of cost weaver. There's good research that shows that system engineering and model-based systems engineering reduces errors to an order of magnitude.
I've got one for Ricardo. This will bring back past life. So, if we're now going to curate our models and do all of these things, you know that designing for reuse costs more than designing with reuse. What does that process now do to our engineering life cycle costs, and what motivates a program now to design so others can be more efficient?
Yeah, Ricardo.
9. So what Donna and her talk was, very appropriate to this whole question of you have to invest into keeping these things fresh. Basically, that was my takeaway, right? And the whole question of reuse is sort of along the same lines, is you invest up front, but if you only invest once and you sort of let it decay over time, then you just sort of lost your investment.
Yeah, but the trick is we're investing so that others can benefit from the
Yeah.
reuse. And that goes counter all of our program metrics, right?
Well, I mean, that's kind of what open source is. It's along that vein, and for some reason, there's enough curating and enough investment in open source that it's, in a sense, dominating some of the industries that we're in. So I think it's a fantastic question.
I was just going to say, the models are useful in that in document-based, you had the creators and the reviewers, and they basically reached a point where they thought, okay, we're doing it right, so we can move forward, right? And then they would get to near the end and find out, oh, we're not near the end, or it costs too much. And models, I think the challenge is to make sure all of the stakeholders understand the purpose of the models and how the model evolves, which goes to this whole point of curation and so forth, and trying to, I guess, instantiate that into large organizations, particularly government or whatever, that don't have that bottom line profit thing is a challenge. And I don't know if patterns is the way, but again, going to your open source thing, we have to bring these in, you have to tell the story so that you can harness this potential of new people, younger people coming in and hit the ground running and move forward with it. Otherwise, it'll just kind of lose traction.
And COSI has a joint activity going on with the ASME standards group on standards for model VVUQ of the model itself. And regulators are especially involved in this, FDA and FAA and others. And so the mechanics and mathematics and so on of establishing trust in a model from the standpoint of its own trustability is a key part of that. And it's more expensive, right? And there's kind of a belief in the past that, oh, that's about what people call computational models, simulations and the like, and not the so-called system models or descriptive models. And we kind of convinced people that that's not so, that our models are just as important to be trustable for the same reasons, and it turns out the same principles apply as well as how to do it. So it's become a part of that project. But it, as somebody else said, it really changes the way we account for things dramatically because they're more expensive, they become actual capital assets, and we have to change our accounting, just as you suspected.
So there's a question in the back. Go ahead.
Yeah, so you presented on a lot of the kind of human aspects of adaptation to these new technologies and new approaches. In particular, the idea of a model curator as a human was very interesting to me. And you did talk, and I couldn't quite hear the question, but it sounded like you responded to this about perhaps having machine learning or other systems that are going to serve in the role of model curation. Have you looked at how the demographic changes in the workforce are going to affect this? Because I know that for me, I guess the dirty word is millennial, the polite word is digital native, right? And for me, and people my age, we inherently are going to go to digital systems with a greater degree of trust than we will even a lot of people who are supposed to be experts. So we know that Wikipedia is more reliable than any human curated dictionary. And so the question is, where are you placing the emphasis on your research?
I mean, I've actually been researching this quite a bit. We've done some empirical studies and with 30 experts, model-related experts, and some of the issues around trust and so forth, as well as what I'd call like semi-structured interviews with executive-level people. And there's a generational issue that arises that's been articulated. First of all, executives of all the things that have to do with digital transformation, the one that I hear from everyone that they're worried about is workforce and culture. And it's the clash between very senior people who, this is not my words, but their words, they're intimidated by the new technology and the models. And the people right out of school who, gee whiz, they know how to use these technologies and they can do all kinds of things with it, but they lack this whole experience base that the senior people have. And so there's this contention that arises out of that that's a concern. Just because you can operate the modeling technology and do really good things with it, we potentially have a real danger there. So how do we bring these two communities together? And one of the things that I've been doing in my research program is that out of all the studies around trust and so forth, we've derived a set of heuristics or guiding principles that we've been experimenting with. How do we use these, say, for a team launch to get the different generations of team members together and then have, real discussions about how we make decisions with models, who has the authorities and so forth. There's a whole body of work that we've done around that, and much more needs to be done, but you bring up a key point that I'm very interested in.
So you're saying old people don't trust Wikipedia.
Yeah, exactly. That's right.
All right, one more question, and I guess it's almost time for break. I know you guys are looking forward to it. Go ahead.
I don't know, I was kind of struggling at trying to find a question to gauge the whole panel.
Yeah.
And it keeps changing a little bit as I hear other people ask questions. But if we look at models, and I'm trying to look at how we move forward, and we try to be able to use them from the many different parts of our industries, and they use various different parts. And especially as Jim was talking about business, and they want to find, I guess, some level of metrics on the effectiveness of using models to change the way we do engineering, system engineering, and actually business and program management. I'm thinking about in curation, and let's try to join the baseball in there. We put every kind of model and put a certain set of characteristics based on certain things, almost like a baseball card. And we're able to somehow manage all of these distant baseball cards within a certain curator. And there's certain things that we get certain rule of thumbs as, let's say, a manifesto to put on there on how to use them. But the patterns themselves, how they interact with other models that we've created some level of standards, where we get certain normative best practices of using this model or method or pattern. Are we mature enough to start populating some kind of database that would be useful for the community as a whole? Or are we still too primitive? Our capability model is not up high enough to really start doing that. And is that something that we're collectively working towards? Or is this something that, we're just still running around like a bunch of ants? Ants seem to, after a while, after you dust up the anthill, they did start organizing and putting everything there. Where are we right now? Where do you guys think we are?
First inning.
Or is that even a goal? Kind of what I described.
Well, I think Troy has a key part of this in terms of, I think one of the important things and how, all of our topics really highly interrelate and that we're starting to have much more conversation and collaboration around this stuff. So I think it's like the precursor to getting to the point where we have the database, but that's Troy's job.
So within transformation, actually the work that Bill mentioned, BVUQ, we have this wrapper essentially. Bill, you might want to elaborate on that because I felt it was right at this question. So we want to share a little bit about that product.
One of the patterns that's been put together in the course of model trustability is it's called the model description pattern or the model VVUQ pattern, and it's a collection of what is currently believed to be all this stuff that we think we should know about a model, its pedigree and trustworthiness and purpose and range of applicability and all those ideas and past experience wrapped up in a pattern that's the same no matter what the model technical structure is, because it's a model after all, and no matter what it's about. And so it's a form of metadata that's neutral and can wrap around any model to help describe some of these mysterious things. And that includes past experience with it. As we accumulate it, you'd hope to accumulate some of that history. As you asked the question, I was thinking when Billy Bean was doing his thing with statistics and all, there was a period of time after which other teams emulated it, right? But they had to build up some experience first that said, because everybody thought he was crazy. And then after a while, they built up some baseball statistics, not about the individual players, but about the outcome of the team, right? And that's sold people. So it seems like the point of what you're getting at is we need to build up experience and statistics that are comparable about the results here, right? That's why the models of what we call System 2 are important. And we're still, I think, early in that process, inning 1, as you said, right? So,
Go ahead.
So I was in a workshop about 2 months ago with digital twins, which is a very strong technology that's coming up. And we discussed this question. And the conclusion was the following, that if you want to have the ability to build digital twins for various systems or components, you have to start paying attention to interfaces and standardize the interfaces so that they become interoperable. In other words, most of the libraries I've seen in model-based system engineering, they focus on components. If you're going to have compositionality, you have to pay attention to interfaces. And then the interfaces, the conclusion was it's easier to standardize because they are somewhat non-competitive. In other words, if you're company A and company B, you compete. If I standardize the interface, you can both play. The components are a little more dangerous. So I don't know what your thoughts about that, but I like that idea. That pushing compositionality, pushing interfaces as well as components, and making the interfaces interoperable and more or less common and well standardized, it will help in the development of models and model-based engineering as well. I would like to get your comments about that. But that was the conclusion of that workshop, and it was in the DMBI in Chicago. And the whole day was, and almost all companies that were here, they had a design there about how to build digital things for airplanes, for cars, for factories, whatever.
Okay.
Agreed. Right, yeah. Back to the point that Bill made about what's the smallest model of the system. You're missing interfaces. You're missing a really critical, important
The
part
importance of
the model.
interfaces comes from the following thing we know from computer science. Even if you talk about programs, if you want to have certain properties of a composed program, let's say deadlock-free or liveness, if you don't pay attention to the interface, then you're not going to solve the problem. Because with a theorem that says, if you have system A and system B, so, and they're both deadlock-free, if the interface has these properties, then the composition is deadlock-free. So we need this kind of things for systems to be able to compose and compositionalize. So in my opinion, this has not been emphasized.
And so, let's see, a way to put it. All the bad things in a product's life happen there. Right? So we need to pay attention to them, right?
Right.
All right, so we've gone through our time. Hopefully this was an interesting experience for you. We're going to continue this experience we're back at 3:30. 3 o'clock is the break time going on.